Let us start the second lecture of the appendix. In this lecture, I will explain major stream of computer science, that is, research on applications of computation. There are three major application areas: simulation, data mining, and artificial intelligence. Let me explain these three application areas in this lecture. In these application areas, we can indeed see how computation gives us a new and clear view. Let us start the first application area, simulation, or more precisely, computer simulation. A simulation is to create a pseudo-reality on a computer. Roughly speaking, simulations are used to conduct virtual experiments. Though there are many ways to use simulations, we can categorize them into three types based on their application purposes. First one is for science and technology. There are experiments that could not be conducted in physical experiments, and instead they are conducted on a computer to make new discoveries. For example, computer simulations may be done to figure out what a black hole is made of and how do interstellar materials move. The image here is from one such simulation. These are not something you can actually observe, so simulations become important. Next one is our daily lives, where we use simulations for predictions such as weather forecast. For example, like this figure, the prediction of the movements of the tsunami wave after a big earthquake in the sea nearby. The third one is for industrial usage. For example, experiments on aerodynamics. Such a test can be conducted in an actual wind tunnel, but simulations are more popular these days because we can conduct various tests efficiently with much lower costs. Then, what are simulations exactly? The question is, how do you turn something into a computation and have it run on a computer? Let's consider simulations used for weather forecast. The first point is digitization. Remember, I explained before, digitization is like applying graph paper to your focus. When you apply this graph paper to, for example, the passing of clouds, we can use formulas from physics to in some way express how the clouds may move from one square to another. Then simulation is used to see how such movements spread across the total area. This is the second point. After digitization, we derive a formula for computing local movements between neighbor grid squares. Then we can use a computer to simulate the total movement, which may be very difficult or even impossible mathematically. So we use computer simulations to understand global behavior for precise predictions or deriving a new theory. In this way, simulation gives us a new and clear view that we cannot get otherwise.